welcome to this lecture video. So this is the continuation of experimental design, particularly for experimental design. So our topic is, or our objective rather, is to come up with possible problems if we are going to use the following design. So first, let us consider the one-shot cases study, then the one group pretest post-test design, followed by the static group comparison design. So as mentioned in the first video, if we're going to use one-shot cases study, it means that we only have one group and then they will be given only the intervention and the post-test. So assuming that the intervention is the use of a blended learning. So our topic is the effect of blended learning in the performance of the students in mathematics. So what are the possible problems that we can solve if we have the design one-shot case study? So obviously, since our concern is performance, then we're going to ask what is the performance of the students in mathematics using the blended learning. So here, it can be that we have three domains like in the statistics, algebra, geometry, and we can also consider the overall performance. Or it can be simply the performance in general. So assuming that you consider the following, let us modify the problem. So what is the performance of the students in mathematics using blended learning in the different areas such as algebra, geometry, and statistics, and of course the overall performance. So with this, you can already use the one-shot case study and you can already answer this question once you're done with your data gathering. So all you need to do is, of course, just to encode the data or the scores of the students in algebra, in geometry, statistics, and of course, the overall performance. So how will you do that? So what do you need to do is to encode your data in Microsoft Excel. So I have here pre-encoded data, but it is a dummy data. So the first column represents the number of respondents, or rather the assigned number to your respondents. So like 1, 2, 3 until to the last number. So I considered, let us add one more respondent. So for instance, this is the dummy scores. So the scores here in algebra, so the total number of items for algebra is 10. For geometry, it is also 10. For statistics, is also 10. So this is a total of the perfect score is 30. So 10 times 10, 10 plus 10 plus 10. So to get for the score, using the Microsoft Excel, you can just set the command. So this is equal sign and then sum, open parenthesis, and then select algebra 2, statistics. Or it is also possible that you just need the overall performance. So I am, of course, not telling you that you have to consider the different domains or the different areas. But if you want to know, for example, which of the following, or rather, in what particular math do the students perform better using the given intervention to them, you might want also to consider by domains. Okay, so we have here now the scores. So you can also consider converting this into percent score. For example, if the qualitative descriptions in your study represents the performance in terms of the percent score. So to do that, so we will select equal sign. Again, the score all over, this is a total of 30 multiplied by 100. So again, equal sign. So let's get the score divided by 30 multiplied by 100. Click enter. So let's just drag this to compute for the percent score of the students in this subjects. So let's just format the cells because we have too many number of decimals here. Let us just limit it into 2, or we can actually remove it. So for example, this is now the performance of the students. So we have 57, 60, 73, 50, 57, and so on. So you might, for example, consider 0 to 20%, 21 to 40%, 41 to 60%, 61 to 80%, and 81 to 100%. So it depends, of course, on your guide for interpretation. You might want to consider some depth orders for you to describe the performance of the students based on the percent score. So for instance, if the score falls within 0 to 20 or 81 to 100, so of course this is, let's say this is a very poor performance. 21 to 40 is considered poor performance. 41 to 60 is good performance. 61, very good performance. And 81 to 100, let's say that this is excellent performance. So if this are my qualitative descriptions for the performance of the students, so I will use this now to interpret the numbers here. Like if the score is 57, then it means that the students has a good performance in mathematics. And for us to place this in our Excel, if you're going to use Microsoft Excel, you can use the if function. Or if you have only a very few number of respondents here, then you can just manually do it. So in encoding the data, we of course do not need to place 0 to 20, 21 to 40. But instead, we're going to give a codes for very poor until excellent. So for example, for very poor, I'll give this 1. For poor, this is 2. Very good, good is 3. Very good is 4. And 5 is excellent. So of the given values are increasing, which also means that the value of its description is, or rather becomes the higher. So very poor for 1 and 5 for excellent. If you will do it manually, then you have to encode the numerical codes provided or assigned to very poor until excellent. Or if not, so what is now the performance, or in general the level? So this is actually the performance. And this is the percent score. Let's change this into percent score. So if you will do it manually, then for example, for 57, it is 3. For 60, it is also 3.